So we're always asking this question, right? What's the future of energy? Well, what if I told you the answer might be swimming around in a pond? Today, we're diving into a really cool study that asks, could we use artificial intelligence to finally unlock the power of algae as a fuel source? Let's break down what they found. Okay, so let's get right into it. The world is on this massive hunt for clean, renewable energy to replace fossil fuels. We've got solar, we've got wind, but they all have their own challenges. And then there's this other idea, microalgae. I mean, these tiny little photosynthetic powerhouses sound like a potential game changer. But, and this is a big but, turning that green promise into a fuel that's actually affordable and practical, well, that's been a huge challenge.
So, what's the big deal with algae anyway? Well, for starters, it's an absolute beast when it comes to productivity. It grows super fast, and it literally eats CO2 for breakfast, which is exactly what we want. This makes it a really compelling source for biofuels. The tech to turn it into fuel is there, but as you're about to see, it's not quite perfect at.
The main way we do this is with a process called hydrothermal liquefaction, or HTL. The easiest way to think about it is like a giant industrial-strength pressure cooker. You take this wet algae gunk, you hit it with intense heat and pressure, and in about 15 minutes, you've converted the whole shebang, lipids, proteins, everything, into a biocrude oil. It sounds pretty slick, but here's where things get tricky. And to really unpack those tricky details, we're going to lean on the work of a top scientist who decided to tackle this problem head-on, using a really powerful new tool. Our guide for this deep dive is Dr. Mahmoud Karimi. He's a real expert in sustainable bioenergy and, crucially, in using AI to model these complex systems. I mean, this is a guy who's at the absolute forefront of developing the kinds of efficient technologies we need to make renewable fuels a reality. He's exactly the right person to try and crack the algae fuel code. And that brings us to his research, which was published in the Journal of Cleaner Production. Now, this wasn't just another paper on algae. The goal here was to do something that, believe it or not, had never been done before, to use AI to find the absolute perfect recipe for the HTL process, one that would drive down both the cost and the carbon footprint at the exact same time. So before you can fix a problem, you have to know just how bad it is, right? The researchers started by modeling a standard commercial-scale algae fuel plant to see what the numbers looked like without any optimization. And what they found, well, it was a bit of a reality check. Let's just rip the Band-Aid off. The analysis showed that the absolute minimum price they could sell this biocrude for was a staggering $11.70 per gallon equivalent. To put that in perspective, that is like 3, maybe 4 times what you pay for regular gas at the pump. Economically, that's just a complete non-starter. Okay, so where is all that money going? You'd probably guess it's the fancy industrial pressure cooker, right? The high-tech conversion process? Nope, not even close. Of that nearly $12 price tag, a mind-boggling $10.18 is just the cost of growing and harvesting the algae itself. The actual process of turning it into oil is only about $1.50. This right here really hits home what the core economic problem is. And it wasn't just about the money. The baseline process also had a pretty hefty environmental footprint. It was pumping out 0.025 kilograms of CO2 for every single megajoule of energy it produced. For a fuel that's supposed to be green, that's a number that really needs to come way, way down. So you've got a fuel that costs a fortune and isn't as clean as you'd hope. This is where things get really interesting. This is where Dr. Karimi's expertise in artificial intelligence comes into play. The team brought in a specific kind of AI to see if it could find a better way to do things. The tool they used is super cool. It's called a genetic algorithm, and it basically works like evolution on fast forward. The AI comes up with thousands of different recipes for the process. It tweaks everything, like the algae concentration, the pump pressure, the heat recycling. Then it simulates the cost and emissions for every single recipe, picks the fittest ones, the ones with the best results, and then breeds them together to create a new generation of even better recipes. So here's what that actually looked like. First, the algorithm started with a random batch of 30 different process designs. It ran them all through a simulation to check their scores on cost and emissions. Then it grabbed the winners, mixed and matched their best features to create a new batch, and did it all over again for 50 generations. Each time, it got a little bit closer to that perfect combination. So after running through all of that digital evolution, all those simulations, did the AI actually find a better way? Well, the results were both really promising and, honestly, pretty revealing. All right, here's the payoff. The genetic algorithm found an optimal recipe that dropped the price down to $11.27 per gallon. Now, at the same time, it slashed CO2 emissions to 0.019 kilograms per megajoule. Look, it's not a magic bullet that makes the fuel cheap overnight, but that's a really solid improvement on both fronts, achieved at the same time. And let's put that environmental number into perspective. That optimization resulted in a nearly 24% reduction in the fuel's total climate change impact. That is a huge step in the right direction. It makes the final product so much greener than where it started. And this brings us to the real aha moment of the research. What the AI discovered is that improving energy efficiency creates this perfect win-win. It's simple, really. By figuring out how to use less energy to run the pumps and heaters, the process just automatically becomes cheaper to operate and cleaner for the planet. It's this powerful reminder that sometimes optimizing for one thing can give you a huge benefit somewhere else. Okay, so we've established that the process itself can be fine-tuned. But what does the study tell us about the biggest levers we still need to pull to make algae fuel a real-world option? A sensitivity analysis shows us exactly what matters the most. When it comes to the price tag, 3 things matter way more than anything else. Number 1, by a long shot, is the cost of the algae feedstock. Nothing else even comes close. Number 2 is the biocrude yield, basically how much fuel you get out of your algae. And number 3 is the size of the plant itself. Bigger is cheaper thanks to economies of scale. And what about the carbon footprint? Well, the biggest factor there is, again, the biocrude yield. Getting more fuel from the same amount of algae is the single biggest win for the climate. After that, it's all about process efficiency. Things like the concentration of the algae mix and the pressure you're running the pumps at. And all of this brings us to the ultimate takeaway from this entire analysis. AI is brilliant at optimizing the factory. It can find those perfect pressures and temperatures to make the conversion process way more efficient. But even with a perfectly tuned process, the single biggest mountain we still have to climb is the astronomical cost of just growing the algae in the first place. Which really leaves us with this final thought to chew on. We've just seen how amazing technology can be at optimizing the process, the factory, if you will. But the next great challenge, the one that could unlock our green energy future, is figuring out how to optimize the plant, the actual organism. What breakthroughs in biology and engineering will it take to finally make that green feedstock cheap enough? Because solving that puzzle could be what finally puts algae in all of our fuel tanks.